All right, welcome to another edition of Geometry Giants. Today we are looking at GeoGebra. I went to that voice the whole time. All right, so you open up the Geometry app and go to the little settings thing there. And for this unit, you do want to show grid, major grid lines, and you want to show the axes. That's plural axis. Pardon? Okay. And then snap to grid, which means it'll go right to the intersection of lines if you're trying to get there. If you're here, it won't, but if you're right at the intersection of a line, it'll do it. All right, so for now, I'm gonna move, quick move, grab the grid and move it over a bit. I'm just gonna focus on quadrant 1, like this, and I'm gonna make a shape, polygon. Go to the polygon tool, and I don't know, there's a shape. Now we're going to look at translations. The way that I remember translations are different from transformations because translations are nothing like we think they are. Is the translations slide. So it's just a slide. It's moving a shape. So if I took this shape and copied it, duplicate, and then moved it over to here, like that, then I did a translation to the right, and then you count the number of steps. So starting here, 1, 2, 3, 4. So we translated 5 units to the right, or changed the x value, increased it by 5. You see this here is 2, 2, this a, and a1 or a prime is 2, 6, and so it was 4. I don't know why I said 5 so many times. Gonna have to edit that out. So 1, 2, 3, 4. Sorry about that. Good thing I caught it, right? 2, 2, 2, 6. So it went up 4. It'll be the same for all. B went from 2, 4 to 6, 4. C went from 3, 4 to 7, 4. So it slid over 5 to the right. Now, I can go to my More tool. I can go to Select Objects. I can select this whole thing and then just delete it, throw it in the trash. I can click on this, duplicate, go to move, and then this time I'm going to put it up here, and it snapped to the grid there, which is great. So A went from 2, 2 to 2, 5. B went from 2, 4 to 2, 7. C went from 3, 4 to 3, 7, and D went from 3, 3 to 3, 6. So they all increased their Y value by 3. So this slid or translated up 3 units. Okay, everyone with me? I can move this somewhere else. I could put it here and I could ask you the question, by how many units did it translate to the right? And you could answer 1, 2, 3, 4, 5, 6. Or you could do 8, the x value, subtract the x values. 8 minus 2 is 6. And there's your answer, translation or a slide. Now, we can get a little trickier. If, for instance, it goes here. Now, because it's not on the same axis as the original, it's translated to the right and up. So it translated, let's do the x value first. It translated 4 to the right, from 2 to 6, 4 to the right, and 1 up. What I like to do with these is just focus on one point. The whole thing can kind of get confusing. If it happened for one point and it's not a dilation, I'm pretty sure it happened for all the points. So there it is. A went 4 to the right and 1 up. So how did this translate? It translated, the entire shape translated 4 to the right and 1 up. And so there are two things. You can ask someone to, draw a shape translated 4 to the right, and they have to do that. Or you could have the shape somewhere and say, how did it move? So in this case, this would be translating 1, 2, 3, 4, 5, 6 to the right. I'm dealing with just the A, and 1, 2 down. So this is 6 to the right, 2 down. Or if you want to get a little fancier, with so many bright minds in this class, I'm sure they do. You could do x plus 6, comma, y minus 2. This right here, which I wanted to move, but I can't, need my move tool, describes the translation. How did it get from here to there? The x value increased by 6 and the y value decreased by 2. That means whatever the x value is, in this case 2, 4, if you add 6 to the 2 and subtract 2 from the 4, you'll get the resultant shape, image. Okay, this is kind of important. This is a fancier way of saying it. There is a third way, and if you look down here, down, into transform, you can translate by a vector. Vectors are really important in physics, engineering, flight, construction, engineering, physics. They're used a lot. A vector says that any straight line can be made up by two other lines that are at 90 degrees to one another. What? I'll show you. Translate by vector. So I can't see I can't see where what it says, but I think I know. Let me just translate by vector. Help! I'm going to close this. Select object to translate, then vector. So I'm going to select this object. And then what you do is you take an arrow, and you can actually do it anywhere. I'd suggest on the corner, but do an arrow, and you make the vector. You make it where you want it to go. So in this case, I wanted it to go 6 to the right, and it's all relative to this point, by the way. This could be anywhere on the thing. It's 6 to the right, so 1, 2, 3, 4, 5, 6, and 2 down. 1, 2. And there it goes. It ended up in the exact right spot because now you can see it's B prime, C prime, D prime, A prime. So this is a vector made up of x plus 6, this line here. I'll show you this line, the line segments the vector is made up of. Line segment here and line segment here. So it's a vector made up of line EG and GF. We use this for flight to calculate wind speed. As if I'm a pilot. I have flown a plane, but never landed one. That's an old trope for movies, right? Do you know how to fly this thing? Fly? Yes. Land? No. I think Indiana Jones said that. Anyway, Carl will know. 6 to the right and 2 down is a vector. So you can figure out your wind speed, the wind speed of the wind out there, and how you have to fly to make sure you compensate for the wind. Vector, which is kind of cool. So this is describing the vector x plus 6, y minus 2. And that's about it. Let me put this I want to put A on G. Does some brave soul want to tell me what the vector would be, or the coordinates like this, x plus 6, y minus 2, would be to get from A to G? I'm going to pause my amazing video somehow.